Let's do these calculations. First one is we want to calculate the empirical formula of a compound that consists of 0.24 grams of carbon, 0.051 grams of hydrogen, and 0.081 grams of oxygen. We're going to find the empirical formula, or the simplest formula. So what we're going to do is we're going to take all of these quantities and change grams to moles. And the way we'll do that is by using the molar mass for each of these elements. So we got 0.24 grams of carbon and 0.051 grams of hydrogen and 0.081 grams of oxygen. And so a mole of carbon is 12.01 grams of carbon, and a mole of atomic hydrogen is 1.01 grams of hydrogen, and a mole of atomic oxygen is 16.00 grams. We got those from off the periodic table. And so if we do those calculations, grams carbon divided by grams carbon cancels, gram hydrogen divided by grams hydrogen cancels, grams oxygen divided by grams oxygen cancels. So we have 0.01998 moles of carbon and 0.0505 moles of hydrogen and 0.00507 moles of oxygen. So if we were to stop there, we'd have a molecular or empirical formula look like C 0.02, we'll say, and hydrogen 0.05, and oxygen 0.005. Now, where have you ever seen a formula that looks like that? You haven't. They're always integers. So what we need to do is get these all in relationship to the smallest number of moles. So what has the smallest number of moles? It's the oxygen. So if we divide each of these by 0.0507, carbon will wind up being 3.94 moles, and hydrogen will be 9.97 moles, and oxygen will be 1 mole. Well, the 3.94 is close enough to government work to call it 4, and hydrogen is close enough to 10 to call it 10. And so our empirical formula is going to be C4H10O. That's the simplest formula. Now, oftentimes in molecules, they're more complicated than this. They're some multiple of this empirical formula. And so we want to find out what multiple it is for this compound. So we're given it some data that has a molar mass of 148 grams per mole. So what we want to do is calculate the empirical mass and then compare it to the molar mass and see what multiple the molar mass is of the empirical mass, and then adjust the empirical formula accordingly. So let's calculate the empirical mass. So let's calculate the empirical mass. So carbon, hydrogen, and oxygen. 4 carbons, 10 hydrogens, 1 oxygen. Carbon is worth 12.01 grams per mole, and hydrogen is 1.01 grams, and oxygen 16.0 grams. And so we'll have 48.04 grams for carbon, and 10.10 grams for hydrogen, and 16.00 grams for oxygen. We add that all up and we get 74.14 grams per mole for this compound. So what we're going to do is take the molar mass, divide it by the empirical mass. So 148 divided by 74.14 is 1.996. which we'll call 2. And so that means the true formula, or the true molecular formula, is C8H20O2. The next one, what's the empirical formula of a compound which consists of 89.114% gold and 10.80% oxygen? Very similar process to what we did up above in number 6 in this particular example set, except we got percents instead of grams. So what we're going to do is simply, in our mind, change that percent to grams. Then out of 100 grams of this compound, 89.114 grams are gold and 10.80 grams are oxygen. So 89.114 grams of gold and 10.80 grams of oxygen. 1 mole of gold is 196.97 grams, and 1 mole of oxygen is 16.0 grams. 16.00. Grams of gold will cancel and grams of oxygen will cancel. We do this calculation, we get 0.452 moles of gold and 0.675 moles of oxygen. So like up above, we want to divide by the smallest amount. And so 0.452 divided by 0.452 is equal to 1. And 0.675 divided by 0.452 is equal to 1.5. So if we stopped right here, we'd have AU1 or AU, then O 1.5. Well, that's not close enough to government work like up above to be able to round it to a whole number. We really need to get it to a whole number. And the way we can do that is to multiply both of these by 2. In which case AU becomes AU2 and O1.5 becomes 3. So the correct or empirical formula for this compound will be AU2O3.